Thanks for tuning in at Brackeys.
Hello everyone and welcome to this video. This is a recording of the first ever Brackeys live stream that we did yesterday, and it was a blast. I had so much fun, you guys were awesome, and we basically created this dodge the falling block style game. So the recording for that is coming up in just a second. I just wanted to say that this is an extra video on top of the other videos that will come out this week, of course, so don't worry about that. And also, if you want to download the game and play around with it yourself, I have a link to the source code in the description down below. I uploaded it to GitHub, so that's fully available. So without further ado, enjoy the stream, and I will see you there. Okay, so I'm really glad that everything is working. And if you haven't seen this on YouTube, what we're going to be making today is one of those dodge the block kind of games. So I already have the game set up here so we can see what we will be working towards. This is mostly for the beginner to intermediate. We are going to be going fairly slowly forward, so I will be able to explain most of what we're doing. But it's going to be a lot of fun. I can just show the game here while we're waiting for people to join the stream. So this is what we're going to be making. You can see that I have a player here with some amazing art. I did it myself, it's true. And if we hit play here, we're able to move around the scene, and some blocks will randomly spawn in. And one really cool feature that I like is this kind of slow motion death cam. So when we get hit by something, you can see that it slows down time until it loads a new frame, and we have some physics going on there. So that's kind of what we are going to be working towards. In this example, I also have a feature implemented where we kind of make the blocks fall faster and faster as time increases. So if we have time, I will show how to do that as well. Cool. And also, of course, ask all the questions you want in the comments. I am probably bad at paying attention to them while talking, but I will try and answer some of them along the way, or at least we'll do some Q&A towards the end. So yeah, so I think a lot of people are in here already. I think that we should just go ahead and get started. And yes, to the first question, I did use timescale to make the slow motion. But whenever you adjust the time scale, you have to adjust time.fixed delta time as well, because we are doing some physics movement. If you don't do that, it won't be smooth, but we'll get into that in a second. So another sip of water here, and another question. Yes, I will try and upload this to YouTube. So if Twitch stores it properly and I'm able to pull it off their servers, I will definitely upload it. But we'll see about that. I don't know about the technicalities yet. I haven't set up to be able to record this while streaming, so I will have to pull it from Twitch. So if there's any issues, I might not do that. So, okay, so let's get started. So what I want to do here is just go ahead and create a new project. And I'm going to call this one the block dodge game. And it's going to be a 2D project. And I'm going to store it in my projects folder. I have an entire projects folder set up for this, and a lot of bad stuff in there. And I'm going to hit, actually, let's just disable Unity Analytics. And I'm going to hit create project. By the way, if you hear some stumbling around in the background, that's just my cats. They are being kind of crazy today, so they might interrupt the stream at some point. So you can see that I'm here in Unity, and what we want to do is begin by creating the most essential parts of the game, which is, of course, the player and his movement. So let's, or hers, it could be a her. So let's go ahead and create some kind of player. And whenever it comes to doing 2D things in Unity, there's always the default sprite. So if we right click in the hierarchy and go create 2D object sprite, we will see here that it doesn't appear. But if we go over here to sprite and select one of the default ones here, such as the UI sprite, we will see a tiny square with rounded edges. This doesn't look too pleasing. So what I am going to do is to quickly jump into Photoshop. And really, you can just Google for this, or you could use any kind of software. All I want to do is just create something like a 16 by 16 white image. That's it, just a white square. So I'm just going to do this now by going to new and then calling this square. And it's going to be, yeah, let's just do 16 by 16, but really it doesn't matter because it's just one big pixel. And we can zoom in on this and you can change the background, but we are just going to leave it white here. And I'm just going to save this in directly as a Photoshop file, but you could also export it as a JPEG if you wanted to. So let's go to projects, Block Dodge Game, and let's go to assets and let's just save that in here. Actually, no, we won't be creating folders today. This project is small enough that we can do without. So I'm just checking the comments here. Everything looking good. A lot of people from the forum. That's nice to see. And if you see me commenting actually, never mind. Okay, so what we're going to be doing now is we're going to be dragging the square into the UI sprite to fill that in, and you can see here that works just fine right away. And let's now rescale our player a bit. So let's change the scale here to something like 6, and then we'll keep the 1 on the Y and 1 on the Z. We can also take our main camera and move it up, and let's just move it up by something like 4, I believe is going to be fine. That looks fine to me. And we can change the background here, but actually what I want to do is I want to bring in another square and use this as part of the background, because what I had in the other example was this main background color that was kind of the playable area. And then I had a darker background color in the outsides of that playable area to indicate that the player can't move there and that there won't be spawning any blocks there. So let's take this new square here, and he's currently on top of the player. So let's just scale this up, and we'll scale it up quite a bit on the Y. Something like that looks fine. And then we'll do, I don't know, 20, let's do 75 on the X. Cool, so you have something like this, which currently looks horrible. So let's go in and find a cool looking color here. And I went with something kind of red-ish, kind of magenta, like something like that. You don't want it too saturated or it will be annoying to look at. This might even be too much. And then we'll take the main camera and we'll change the background here to that color. And we won't use skybox, we want to use a solid color. And then we can just darken it a tiny bit. So you get kind of this effect. And looking at my other monitor here, which has some different color settings, this looks very saturated, but on this one it looks fine. So it's just one of those things where you'll have to play around with it. As always, I'm just going to continue because it's not very exciting to see me just spending a lot of time finding the right color. So at this point we're ready to save our scene, and let's just save it as the main level. We'll only be having this main level, and because technically the levels are procedurally generated, I mean they are generated at runtime, you most of the time only need one level, so we'll just call it that. And we have this new sprite here. Let's call this one, this is the player, so let's call him player. And we have the square here, which is the background. Cool. So you can see currently our background is on top of our player. And to simply fix this, we could change the order in layer to something smaller, which means that it will be drawn before the player, and so the player will be drawn on top. Or we could go in and add a whole sorting layer. Since we only have this one thing in the background, I'm just going to input something like -2 here and we'll be fine. But please do add a layer if you have multiple things in there. Then let's select our player, hit add component, and let's create a new script. And don't worry about the error that I'm getting down here. It's just something that the Unity editor has been doing to me for a while now. It's kind of annoying, but it doesn't have any effect on the game whatsoever. I've went through a whole Ludum Dare with that error in my console. So for the name here, we are going to select player, how original, and let's double click that to open it up in Visual Studio. And again, I will remember to drink water so I don't sound like an old man at you. So I'm just going to look at the comments here while we are opening this up. I do not have a GameJolt account actually, or anywhere to play my games. You can go to Brackeys.com. I have a few projects there that you can check out. I made one for a jam called Flappy Bird, and that's an alarm going off, so I'll just fix that real quick. Or called Flappy Cow, which was of course a Flappy Bird spin-off about a flying cow. It's pretty cool, also kind of dumb. But you can check that out. Also, in 2 hours exactly, there will be a video airing on the YouTube page that is about creating my latest Ludum Dare entry called Diggin'. So you can go there and check that out, of course. That is also playable through links to the Brackeys page, but I actually haven't put it on the Brackeys page to be displayed there. So go to ludumdare.com for that. But sure. Okay, so we'll continue here in Visual Studio. So what we're going to be making here is some movement controls, and we're going to keep it fairly simple. We're going to be doing all of our movement inside of the fixed update, because that's a good place to do physics stuff, because, well, it runs on a fixed timer, and physics likes to do that. So if you're going to be doing a lot of movement, I really suggest splitting it up into registering the movement in the update and then doing the actual movement in the fixed update. But today we're just going to be using the horizontal input axis, which works fine inside of the fixed update itself. So let's start by getting our movement, and we could do this by going like if input.get key down arrow right or arrow left. But that won't allow for smoothing of the movement, and it will not be usable with the joystick. So instead we'll go here and fetch the input axis. So we'll have this float called x, and we'll set that equal to input.getAxis. And if you don't want any smoothing on this, you can do raw, but I do. And then we put in an axis name, and we are going to be using the horizontal axis, which means left and right movement. And what this will do is it will fetch from Unity information about when we have pressed move right or move left. And also if we're using a joypad, it will throw that in there as well, and it will smooth it a bit out too. So we'll get an x value between -1 and 1 that kind of interpolates, lerps, or smooths from one setting to another. Cool. And one thing that we always want to do when doing movement is multiply this with time.fixedDeltaTime, because this is inside of our fixed update, which is the amount of time passed since our last fixed update was called, and therefore it will make it independent on of whatever our fixed delta time is running at. And then we will have a speed variable. So let's go up here and create a speed variable. It's going to be a float, and we'll call this speed, and default it to something like, I have no idea, let's do 15. And let's multiply that down there. Cool. So now we can use this x variable to do actual movement. And we are going to be moving using a rigid body. So let's go into Unity and add in a rigid body. So let's go add component, rigid body, and then 2D, because we're using 2 dimensions here. And we want to turn on is kinematic. And this will allow us to only use the rigid body in terms of colliding with other objects, but moving the rigid body is completely controlled by us through a script. That's basically what that does. So it doesn't matter that our gravity scale is set to 1, it won't fall to the ground. You don't need to do any constraints or anything like that. It's only moved by us in this script. Cool. And I'm just going to take a look over here. I hope to continue the C# tutorial once I have something relevant to say. I really find that I covered most of the things that I wanted to do when starting the tutorial, and there's a lot of demand for other stuff at the moment, but I don't consider it completely dead either. So we'll see where that goes. Cool. So let's actually use this. So let's first off get a reference to our rigid body component, because we want to move using it, and so we need to reference it in some way. And therefore we make a private rigid body RB called, or rigid body 2D called RB, And we cache this, which means that we find the rigid body on our object and put it into this variable in the start method. So we only do this once. And then here we set RB equal to get component of type rigid body 2D. And it's that easy. That finds the component, it goes down and searches all of the component, finds the rigid body 2D on our game object, and calls it RB. So now when we want to do something with the rigid body, we simply use the RB name dot, and then we can use move position. And this moves the object to a certain position, checking for collision along the way. And the useful thing here is that the position that we want to move to is our current position plus some x value. So we want to move to our current position either a bit to the right or a bit to the left. So our current position is called rb.position. And then we can add on to that, and we can't just do x because this really doesn't make sense. Our current position is in 2 dimensions. It's in x and y, to the left and right and up and down. And then we're adding on a one-dimensional value. That doesn't make any sense. Instead, we use vector2.right. And this is the same as saying that we want to go 0 up and 1 over to the right. So 1x and 0y. And then we can multiply this with our x variable. And that basically means that instead of always going 1 to the right, we now can go -1, which means to the left, or somewhere in between. So that will correctly move our rigid body. And we can actually go and playtest this now, if I'm not mistaken. I'm just going to clear the console there because I freaking hate those error messages. And you can see that I can now move from side to side, and it smooths out the movement a bit, which is super cool. I can do that using A and D or the arrow keys or whatever. Good. One problem that we do still have is if we try and do this, we can fly off the map. So let's just make sure to clamp this movement a tiny bit. And we do that by going up here and declaring some kind of float. And we'll call this the map width. And we'll set that equal to something like, I have no idea. Let's set it equal to 20, 10. Let's do 10. Let's do 5. Let's try 5. So the map width here is basically a way for us to choose how wide our map will be. And the way that we then clamp this value here, which means limit the value between, so it doesn't go above the width, is to use math.clamp, which takes in a value that it should limit, then a minimum value and a maximum value. It's very simple. So let's split this code up a bit. Let's take all of this, which is the new position that we want to move to, and let's store that in a temporary vector2 variable called new position. So we set that equal to all of that. Then we can do new position dot x. So we only want to edit the x value here, and we can set that equal to, and then we can do math.clamp, and the value that we want to limit is new position dot x. And we want it to be between minus map width and map width. Okay, so if that makes sense. And yes, technically our map width is then only half of the actual width because we're doing both the negative and the positive. But don't be technical with me here. We are programming. And so let's put our new position into the position that we want to move to, and now that should indeed be fixed. So let's hit play here, and we should be able to move to from -5 on the x to +5 on the x-axis. So that's perfect. I'm going to have yet another sip of water, and I am going to continue. So what we could maybe add now is some falling blocks. That is, of course, essential to what we're doing. So let's go ahead and start by adding some blocks. Let's create some blocks here. So let's drag in the square again. The basis of all nice things is a square. And I don't know, that didn't make any sense, but we are going to go with it. And we're going to set an x value of 10 and a y value of something like 4. And then we can call this a block, And we can even add a block component to it, but we'll wait with that. We'll do that later. And we'll add a rigid body 2D. And we don't want this to be kinematic because we want it to fall on its own. And we can add a collider. More specifically, we can add a box collider 2D. So we can see that that just fits this collider very nicely. Actually, it fits it so nicely that it's almost hard to see the green line here, but it is there. Cool, so we can then move this up, and when I now hit play, it's very simple, it falls down. But it doesn't collide with our player. What's wrong? If we look at our player doesn't have a collider. So we'll add a box collider 2D to that as well, and now it should collide with our player, but the game doesn't end or anything. We'll add registering that in a moment. Let's first begin by actually spawning out these blocks. And this is the most difficult part of the tutorial, and it is a bit difficult because we are going to be using an array. And an array is just a list of items that where we associate each item with an index. So we say that we have 3 items. The first item we associate with the number 0, the second one with the number 1, and the third one with the number 2. And then we can say that this list, and then we use some bracket keys, 1 then references the second object. So in order to actually get some use out of this information, let's go ahead and create an empty object. And this will be responsible for spawning our blocks. And we'll call this one the block spawner. We can then move this up and off the screen so that all of our blocks can just have the same Y position. We can move that to the top of the hierarchy just for ordering's sake and add a new component called block spawner. Create an add. Let's double click this to open it up in Visual Studio and reload all, and everything's fine. Cool. So we can delete that namespace there. It's really not necessary. And then we can add a public and then transform. And remember, transform is how we reference an object that we want to do some kind of position or rotation checks with. So we could actually let's do a transform here. So basically the way that I want to do it is I want to create a few spawn points, something like 5 spawn points up here. And then I will have the computer choose one at random. So we will have a list of all of the spawn points. It will choose a random spawn point, and that is where no block will spawn. So it will just choose a single one, and it will spawn a block on all of the others. And it will do that on a fixed timer. So let's actually create this array, this list of blocks. And we make this into an array. Right now it's just a singular thing by using these square brackets. Now it's a list. It's that easy. So now we can call this our spawn points and close that off. And what this allows us to do is if we head back into Unity, remember to hit save, we can see that we now have a spawn points list, and we can increase the size of this list to, let's say, 5. And we can now drag in objects. I don't want to drag in the main camera, however. I want to create some empty objects that we can use for this. So let's go up here, hit create empty. Let's reset the transform on that. Let's call this one a spawn point. And let's have the first one be at 0, 0, 0. And that is relative to our block spawner because it's a child. Let's duplicate that and move this over by 2 on the X. Duplicate again, move over by 4 on the X. And these values, I know them because I've done this once before. I'll play around with them. You can even take the block up there to use as a reference if you want. And we're just going to duplicate the first one here once again. Now do a -2 on the X and duplicate that one and do a -4. And the way I'm duplicating here is by going Control D or Command D if you're on a Mac. So now we can select all of our spawn points, and we should actually, what we're going to do, and I should have done this before, you can go ahead and select an icon for this, which I am just going to do. So that will just very clearly show that we have some spawn points up here. For some reason, you can't edit multiple icons at once. You could quickly turn this into a prefab if you wanted to, but there you go. So now we can actually visually see the spawn points in the scene, but not in the game. Cool. So now we need to drag all of these into the list, and we could go like this. That takes a lot of time if you have many objects. I only have 5. So instead we could remove or change the size here to 0, lock the inspector, then select all of the spawn points by using Shift, and then drag all of it over here, and it will insert all of them right in. It's a super handy trick, and then we can unlock the inspector once again. So now that we have this in our spawn point array, we can go in and actually use this to do something. So right now we'll just be doing this in the start method, and what we want to do here is we want to select a random spawn point. How do we do that? We use a random number. So Unity provides the ability to give us a random number between a minimum and a maximum value. And because all of our spawn points are associated with indices, with numbers, we can just use that number to get the spawn point that that number is represented by. No, that to get the spawn point that is connected with that number. Okay, so now integer, we are creating a new temporary variable here, which is an integer, just a flat number, and we're going to call this the random index. And we set that equal to random.range, and this is Unity's way of getting a random number, and we're going to get that between 0 and then spawn points.length. We could just input 5 here and that would work just fine, but then we would have to change it every time we added or removed a spawn point. So instead we just get the amount of spawn points in the list by using .length. Cool. Then what we do is we loop through all of the spawn points. So we say for int I equals 0, I is less than spawn points .length, then we want to do something. So this is a way of saying that we want to do something X amount of times. In our case, we want to do something spawn points.length amount of times. That means 5 times. So for each of our spawn points, we will do something. And then we have a number associated with each iteration of the loop. So the first time I will be equal to 0. The second time it will be equal to 1, all the way up to 4. So we can use this I to get the spawn point that we want. That's basically what this means. So it declares a variable I. It says that we want to keep going until we've reached the end of our list, and it should increment I by 1 each time. So now we can get a random spawn point by going transform, and we'll call this one the spawn point, or maybe even random point. Let's not do that. Instead, what I want to do is I want to check if random index is equal to I. So if this time that we are looping over, this index that we've reached, this spawn point, should be the one selected up here. If it's the one that we chose, the random single one that we don't want to spawn a block, if that's the case, well then we don't want to do anything, so do nothing. But if it is not, and we do that by simply putting an exclamation mark up here, if it's not equal to that, then we want to do something. So let's actually do that. And what do we want to do? We want to spawn in a block, and we do that by using the instantiate function. So let's go up here and let's create a reference to what we want to spawn in. And that's a game object we want to spawn in. And the game object that we want to spawn in is, let's just call it the block prefab. So we want to spawn in our block prefab, and we want to do that at a certain position. More specifically, we want it to be spawned at our spawn points position. So we'll do spawn points. And the way that you get, when iterating through the spawn points here, the way that you get a spawn point at a certain index is always using these square brackets and inserting the index. So if I wanted to get the first spawn point, I would do 0. The second one I would do 1, 2, or 3. You can input the index and it will give you the spawn point. But in our case, we want to get the ith spawn point. So the first time we go through, we want to get the first one. The second time, we want to get the second one. And we want to keep doing this unless, of course, we get the it's the random spawn point that we've chosen we reach, or we run out of spawn points. So we want to use spawn points I.position, we want that position. And whenever you don't want to rotate anything, you use quaternion.identity. That just means don't do anything to it. And really don't ask me why you have to put in quaternion.identity. It is, quaternions is a whole field in mathematics, and it's super complicated, and we're not going to get into it. Just learn that by now. Memorize it, and we won't comment on that again. How did I do the auto intelligence thing for the for loop? You mean the auto completion there? Basically, what you do is you just write for and then tab, and it will give you the ability here to change the variable name, such as the x, tab on, and you can change the condition here to say spawn points.length, and then you hit enter, and it will put you down here. So it's a really handy shortcut. You can do that with switch statements as well, while loops, a lot of stuff. Cool. So now we're instantiating that, and everything's looking good. And that was the most difficult part. It's over, I think. So let's see if this is working. So let's jump into Unity. And we have the block prefab slot here now. And instead of just dragging our block directly in there, let's drag our block down into the inspector. We've now turned it into a prefab. That means that if we have multiple blocks in here, I can put in multiple of them and change something on one of them and hit apply. It will be transferred to the other object. So that is the awesome thing about using prefabs, and also we can reference them without having them in the project. So let's select our block spawner and drag our block right in there in the block prefab slot. So now when we hit play, we should see right away it spawns, yes, it spawns a block for all of the spawn points except one. And it should be a random one. It is, so it changes every time. However, it currently does this only once, and that is in the start method, which means right at the beginning of our game. So let's have it do this on a fixed timer instead. And to do this, we change this to be done in the update loop. And actually what I want to do is I want to take all of this code and I want to move it into a separate function. I just cut the code there, Control X. You can also just Control C and then delete it. And then void. And we'll call this spawn blocks. And we can paste all of the code in there. And now instead, whenever we want to do all of this code, we simply write spawn blocks. We simply called it that way. It's now a separate method. But we don't want to do this every frame. So update is called every time the computer draws a new frame, which means in most games on decent computers, a lot of times, between 30 and 200, 500 times. So that would be a lot of blocks. So what we're going to do instead is we are going to keep track of time. More specifically, we are going to have some kind of private variable, some kind of private number that stores the time for the next time we want to spawn a block. So it will just be a number, the amount of seconds lapsed since we started the game, and then until we want to store or to spawn. So let's say private float here, and it's going to be a, let's call this the time to spawn. And we're going to set this equal to 2. That means that there will, that 2 seconds after we start the game, the first block will spawn. Then we will be utilizing time.time. This is a Unity variable, and basically it is just the amount of seconds that has passed by since we started the game. So right when we start up the game, it's of course going to be 0. 5 seconds after, it's going to be 5. And the cool thing about this is that we can use it to determine whether or not it's time to spawn and the next time we want to spawn. So you can see here that if we go if time.time is greater than or equal to time to spawn, well then we want to spawn something. The time that we want to spawn is after 2 seconds. There's gone 3 seconds by, which means that time.time is greater than or equal to time to spawn. And then we want to spawn something new. So let's do that here. Let's move spawn blocks in here. And then we want to change time to spawn to be, again, some amount of seconds after. And this amount of seconds here is normally what we refer to as a rate. 1 divided by the number of seconds is the rate, or we could just have an interval. So let's do a public float here, and let's call this the time between spawns or between waves. let's call it waves here, and it's going to be defaulted to, let's say, 1 second here. And what we can then do is we can say that time to spawn down here, so right after we've spawned a wave or some blocks, we can say time to spawn equals time.time plus time between waves. So now time to spawn, if 3 seconds have gone by, and this was 2 seconds originally, this will now be 3 seconds plus time between waves, which means that it will be 4 seconds. And then the update loop will keep running until 4 seconds or more have passed, and then it will spawn the blocks and again increment by 1. So we keep doing that in an infinite loop. All right, so let's try this out in game. I'm just going to make sure that everything's working here. It looks like it. And let's hit play here. And we should see after 2 seconds, it spawns the first wave, the second wave, the third wave, the fourth wave, and so it keeps on going. And you can very easily adjust time between waves to make waves spawn faster and faster. And I definitely recommend you to do this, but we won't be doing it here right now because, frankly, this stream has already lasted for long. So question time, I'm just going to look over here just for a moment and then we will continue. Someone asked why I had to use the quaternion. Please don't ask that question. It has something to do with how you rotate and keep track of... I don't want to explain this. Now that we've reached the Patreon goal, I'm going to do a Game Math Essentials course. Might have something in there. Well, we'll see. Other than that, not much here. What happens if you use forces and stuff like that in update instead of fixed update? Well, most of the time things will seem like they're working, but you can get some really weird behavior. When you do physics in update, collisions won't work properly. You will have jittery motion. It's just a mess. So move it to fixed update, especially if you're modifying this kind of stuff in update, and then, for example, want to have your main camera follow the player. So if we do a player movement in update, want to have the main camera follow the player, that will be a very weird motion because they're doing it in the same loop. They need to be separated out. Unity has some great chapters on this if you want to read up on it in their manual. Cool, so let's continue here by actually making something happen when we hit the blocks, because at the moment here, things are a bit dull. We can just keep doing this infinitely. So what we'll do is we'll go in and modify our player script to do this. So let's double click on our player here. And let's add a new function here. And this is going to be an on collision enter 2D. And you need to write this out exactly as I've done here. Normally you're able to change your method names to whatever you want, but this particular function is what we call a callback function. And that means that Unity decides to call this for us. Just like start and fixed update and update, this is called not when the game starts and not when a frame is drawn, but whenever we hit something using our 2D collider. And then we can do things down here, such as destroying the player or ending the game. So in our case, we're going to be ending the game, but let's just check that this is working first. So let's say we got hit. Just debug.log that, just throw it out in the console. So we should see now that when we collide with something that we get hit, and that is indeed true. And it does that multiple times, but it won't matter because, well, we're only going to be ending the game once. And we could go ahead and end the game right here, which means reloading the game and adding that cool matrix effect and all that. But what I want to do instead is I want to create a separate script to do this. And it's great to separate out your code because I don't think ending the game really has anything to do with player movement. So let's create another empty object here, reset the transform, and let's call this one the game manager. A game manager is one who ends games. So now let's hit add component, game manager. And let's hit create an add on that and double click the game manager. And in here, we'll just make a public function, just a public void called end game. And then this will be called from our player script. And then we can do all of our ending game sort of code in here. So all we can do now is maybe just debug.log, the same thing here, ending game, and then we can just call this from the player. But how do we do that? How do we reference this game manager that sits on this object with this component that has this method? Well, the way to do it, one way to do it, there's plenty of ways to do it. One's more correct, one's really not correct. And the way that we could do it is that we could use a game object, or actually a find object of type, and then you give it a type. So we find an object of type game manager, and then you can simply use dot end game. So there we go. We now had access to that function. So we're basically just searching the entire scene after an object called with a game manager component. This could be called anything. It doesn't have anything to do with the name. It just needs to have a game manager component. So that also means if you have multiple game managers, this code will become weird. So don't do that. And it's not very safe and it's not very performant, but it works. So we'll continue with that. So in our game manager, we should now see, if we hit play here, that it will throw out this debug.log statement. And it does. So that's perfect. And now we can separate this with some other code. Let's go in here and use Unity Engine .scene management. And then we'll just do scene manager. And you need to do this whenever you want to load new scenes. Scene manager .load scene. And the scene that we want to load is our current scene. So we could just go in here and put main level or 0, because it also uses a build index and ours is first in the list. But we could also use scene manager .get active scene. So this will just get the scene that is currently active and then use that .build index or name. We'll just use build index here because integers are smaller than strings. Cool. So that will reload the scene, and it will do that immediately. So this one look cool, but it will work. So if we hit play here and we die, we reset. It's already a game. Really, it is a game. It's not very rewarding, but it's a game. Cool. So one thing that I want to fix before doing the matrix stuff, I'm really teasing that towards the end, is I want to make sure that our blocks, when falling down, get destroyed at some point. So you can see here, okay, so I actually have to play the game a bit here to show you. So I'm just going to kind of move. Okay, I suck at my own game apparently. The pressure, it's too much. Okay, so you can see now a lot of blocks have fallen down. And if we look on our main level, all of the blocks are now in the scene. If you are good at the game and play a lot, we're going to have way too many objects in here. So what we'll do is we'll just select the block and add a quick script to this that will make sure to delete it once it reaches, let's say, a y value of -2, somewhere down here. Let's create this block script. And there are multiple ways of doing this. You could also just put a destroy timer through the block spawner here, whatever. And we're going to do this using the update method. And what we want to do is simply check if our current position, so transform.position.y, if our y component is less than or equal to, actually let's just do less than, something like -2, well then we want to destroy ourselves. So we want to call destroy on this object. So we reference that by game object with a small g there. So now when we hit play, and it's just a very quick fix, you will see if you look over here that the objects are destroyed again. So it's removing them just as quickly as it's spawning them back in. So that's perfect. That just helps keep the hierarchy clean. And now for the matrix stuff. Okay, so before we get started with that, just wanted to see if there's any questions. Let's see here. Okay. Yeah. One guy commented when he's working with the game manager, he is referencing it through a property. That's a much better idea. Have some kind of singleton pattern, but I think the scope of this tutorial is a bit too simple to get into static game managers and all that. So let's just continue right away. So what we want to do here is we want to head into our game manager where we end our game. And the problem here is we want to kind of delay this a little bit, because when we just load a new scene, we don't have any time to see the matrix effect that we're going to be adding. So what we'll do instead is we'll use what is called a coroutine. And whenever we're using coroutines in Unity, the syntax is super weird and doesn't make any logical sense unless you understand how IEnumerators work and what an IEnumerator is. But I will just show you how to do this and then just follow along and pick up on the points that you get. So you can see up here, when we're using coroutines, we need to have this using system.collections. That is important. Then what we do is we create, instead of typing in void here, we create another function of type IEnumerator. So we say that the function has an IEnumerator return type. And this is a weird word, and we'll just continue on. And we are going to call this restart level. And you can see all of the other syntax is just is a completely normal function. And then what we have the ability to do here is we have the ability to type in yield, return, new, wait 4 seconds, and then the amount of seconds that we want to wait. So in our case, let's wait just a second. Let's just wait 1 second. So this will wait, and then it will call the code down here. So after 1 sec, and this is before 1 sec. Okay, so that basically means that we can take our scene manager's code here, the switching scenes code, and we can put it down here. So now it will be called after 1 second. And then we need to call the restart level, and normally we would go in and do this. But with coroutines, of course, the syntax is different. So we have to do start coroutine and then do restart level. And remember the parentheses here. We need start and end for the restart level and a start and end for the coroutine. Cool, so let's save that, head into Unity, and now we shouldn't see any matrix things or anything like that, but we should see that it waits a second before restarting. There we go. So now to the actual changing of time. What is time? I don't know, but we're going to change it. So you can see here that we have time.timescale. Time.timescale is a number that is usually set to 1, which just represents a factor or something that Unity multiplies every code that they do with, basically. So it's just our current time. If it sets to 1, it's regular time. If it's 0, time isn't moving. -1, we'll go backwards. I don't think they actually support that. 2, it will go twice as quickly. You get the point here. So our time scale can be modified very easily by simply setting it to a new variable or to a new value. In our case, I want to have a tweakable value up here, a public float, and we're going to call this the slow down factor or something like that. So slowness almost sounds cooler, and we'll have that be something like 10. So we will move, or time will move 10 times slower. Then we can set timescale equal to 1 and then divided by that 10. So that means effectively 0.1, but we don't want to put in 10 here. We want to put in slowness. However, when we adjust time.timescale, we also have to adjust fixed update, because when we are doing things inside of our fixed update, we use this value called fixed delta time. And this isn't changed together with a timescale. So if we want that to be smooth, we have to change it. So let's use time.fixed delta time, and we want to set that equal to time.fixed delta time divided by slowness. So whatever it currently is, divided by that amount. Cool. Then we want to wait for a second, then we want to load a new scene. However, we want to set our time back because our time is transferred to the new scene, and so we need to set it right back. So we could set timescale back to 1 there, and time.fixed delta time, we want to set this to time.fixed delta time multiplied with slowness. So we divide, and then we multiply, and it evens out, and it's back to the original state. However, when we wait for 1 second, this is also affected by time.time scale. So if we slow down by 10, wait for 1 second here, we will actually be waiting for 10 seconds. And that's a lot of time to wait for an end screen. So instead, what we're going to do is we're going to do 1 divided by slowness here as well. So that will make sure we always wait exactly 1 second real time. Awesome. So I believe that code should work now. Great if you understood what coroutines allows you to do. I really don't understand you or expect you to understand everything about them. So let's hit play here. And look, my cat is joining in on the screen. Say hi. Say hi. Okay, I'll put her down here. So if we get hit by a block here, you can see that time slows down. And we have this cool matrix effect that I showed you before. And just makes it very clear to the user that the game has ended. The last and very final thing that I wanted to show in this stream was just how to make the blocks speed up so that the game becomes increasingly harder over time. And a very easy way to do this is to go into a block script and modify it a tiny bit, because we have already a variable available to us called gravity scale. If we set the gravity scale of the blocks to 2, they will fall with twice the amount of gravity, which means twice as quickly. So let's just, in here in the script, change our gravity scale depending on the amount of time that has passed since we loaded the level. So let's do, and we only need to do this right when they're spawned in. I don't think they need to increase over their lifetime. They just need to begin or to spawn with a greater gravity. So our void start here, that's fine. Then we can get a reference to a rigid body. We know how to do that. Get component, rigid body 2D. And then we do dot. And then we do gravity scale. There we go. And of course, this is set by 1 set to 1 by default. So we want to plus equals that. That means we want to add something on. So if I put in 1 here, we will get 2, and so on. So we want to add on a value to that, and the value that we want to add is time dot time since level load. We don't want to use time.time because that is the time since we started up the game. So if we die and it then reloads the scene, we want this difficulty to reset, or else it would just continue going crazy. But we want the amount of time since we loaded the level. And then, of course, this would very quickly become difficult, because this means that each second this will get increased gravity scale by 1. So after 1 second, it will be twice as hard. And that's not desirable. I think we should divide this by something like 20. And we can maybe go in here and define a variable here that we will call gravity scale, I don't know, factor, something, gravity scale, I don't know. I'm just gonna put in 20. I don't have a good name for this. I'm just gonna hard code it in. You can put in a variable if you want. You know how to do that. So yeah, time.time since level loaded divided by 20. That's fine. So now let's hit play, and we should see. And I'm going to show you this. So I'm just going to pause this here. These blocks now have a gravity scale of 1.15. And if I continue the game, let me switch over real quick here. These blocks have a gravity scale of 1.2, and the ones after have a gravity scale of 1.25. So they will increase in speed. And I'm just going to show you this by maybe playing the game a little bit. Please don't tease me if I lose. I lost on the first. Okay, so this is going better. I'm a bit lucky there. Okay, so you can see actually visually that the game is becoming harder, and I think we are at a pretty nice difficulty state here, so that's fine. That's basically all I wanted to show you. If you want to continue working with the game, I really suggest adding some kind of score. Just some timers, since I've shown you how to do so much with time. Try and add a UI element just in the corner of the game or whatever, somewhere on the screen, that displays the amount of time that has passed, so that the user can be proud of how long he was able to survive. Or you could have a wave counter, so each time it spawns a block, or spawns a wave of blocks, it's going to increase by 1, and you can see how many block waves you've survived. That would be ideal for this sort of game. I think we're out of time for now. This stream has lasted so crazy long. I will do a bit of question and answers here, so you can go ahead and leave them in the comments here or in the Twitch feed, and I will see what I can do. And yes, I am just coding what my cat tells me. They are my biggest inspiration. From where can we get those files, your Unity project? I haven't made them available yet anywhere, but I will. I'm just going to switch to this mode here. I will definitely upload them somewhere and let you know. I know that's super dumb, but I will definitely be able to make sure to upload them. I will probably publish them to the Brackeys website somewhere, but I will make sure to publish a Facebook post and a Twitter post, and maybe mention it in a video. We'll see. So follow me there if you want to be notified about that. I should do it rather quickly. When the stream ends, I will figure something out. So yeah, but it's not available yet. I'm not going to. Maybe I'll upload it to GitHub. It's actually not a bad idea. I mean, it might be a bit much. Some beginners seem to be confused with GitHub. I understand why it has a lot of functionality that is unusual. But yeah, I could definitely look into that. When will you introduce currency in your tower defense game? That is soon. As soon as we get the missiles done, I think it is about time for currency. I just wanted to get a secondary turret in there because it looked super weird with the UI only displaying displaying 2 copies of the same turret. Let me see here. The microphone I'm using is an SM7B from Shure. So it's a Shure SM7B, and it's plugging into a Motu audio interface. Cool. What kind of education do you have? Danish terms are fine. The Danish term is gymnasial. That means somewhat relates to high school. I haven't taken a longer education in programming or anything like that. I am pretty much self-taught on much of this, but I've been programming for a very long time now. But yeah, I don't have any official degree or anything like that. That's actually a question I get a lot, so thank you for asking that here. Am I thinking of doing an 8-bit 2D RPG? That was very specific. I am not thinking about doing an RPG at the moment. I think most of the time RPG projects tend to get crazy very quickly and demand a lot of content. And I think that would steal emphasis from a lot of the other projects we have going. Things that I'm working on is a lot more on the 2D tower defense, a lot more on 2D tower defense, a lot more on the tower defense, more multiplayer FPS videos. Now the Game Math Essentials. I'm also, don't tell anyone about this, working on some Blender tutorials maybe. Very much work in progress. Don't quote me on that. And yeah, a lot of cool stuff to do. So no, an RPG is not really on the schedule at the moment. I am 19 years old. That is my age, but that's just a number. And how exactly does Patreon work? I will support you. It will automatically get my money every month. Yeah, pretty much. Well, Patreon is just pretty much like any other crowdfunding site, except you're able to make a monthly recurring donation, and you're able to cancel it at any time. Donations are charged at the beginning of the month, and it might take up to 72 hours, but that is how it works. You can choose a completely optional amount. You can choose a price tier. Generally, you just have complete control. And that is something I haven't mentioned. If you like this sort of stuff, if you want to see more of it, if you want to see more videos on all that, thank you so much for the support I've already received here. But if you want to see more, you can go to the Patreon right there, patreon.com/Brackeys, and leave a donation. really helps me out a lot. I mean, this would not be possible without that extra money each month. So you guys are awesome. Thank you so much for that. But yeah, that's basically how it works. Yeah, age is just an integer. Yeah, it's true. I was not at Gamescope in Aalborg. I'm sorry. I am Danish. Yes, that's true. I am a Dane. I have done some client work in the past. I don't do much of it anymore, but I do have to do a bit because the money, even with Patreon, is not necessarily enough. So I do a tiny bit of client work. Am I going to do a 3D platformer or MMO? I'm never ever going to do an MMO tutorial. I'm sorry if that was what you were waiting for. You can go ahead and unsubscribe. That is a bad idea. It's just too much to show in a tutorial video. If you're going to do an MMO, you need a team. I'm not a team, and I cannot explain all of the steps that goes into an MMO. You also need cash as well. I've seen some guys on YouTube who create who's working on an awesome MMO project. I believe they're just 2 or 3 people. They've been working on it for like 5 years. You can go and search for Unity MMO project or something like that. I'm sure it will appear. I can't for the life of me remember the name. Those guys are amazing, but that is really the closest I've ever seen anyone get to an MMO in Unity with a small team. So it's very difficult. Will you ever make Unreal Engine tutorials? That is very possible. I actually wanted to do it a long time ago, but then my education got in the way and I had all sorts of excuses. That might be a thing. I'm by no means an Unreal expert, but it is a cool engine and I don't necessarily want to do everything in Unity. I probably will never stop using Unity, but of course that might be nice as an addition, of course, to the regular videos. Any good suggestions for a way to make an installer? That depends on what you are installing and for what OS. If you want to see some recommendations when it comes to packaging up your games and stuff like that, go watch the second to last Make a Game video called Make a Game Standalone or something like that, exporting to standalone. That shows a bit about that. Also, yeah, I would just go there. I'd talk about it there. Do I have any plans to remake my older videos when you were using Unity 4 with Unity 5? Not at the moment. I think we have a lot of other very exciting community things going that I would rather focus on. But if the demand is there, I might do it. I'm not close to that sort of idea, but it's not really a priority at the moment. Let's see. Advise a book for C#. Let me just find here for you the book that I read upon starting, and my mouse has quit on me now, so I will have to restart that somehow. Just a moment, I will have to restart my mouse. See, this is kind of the bit that I cut out when doing a video. That's the exciting part of a live stream. You never know what can happen. Mice quit. Everything goes crazy. Explosions. Yeah, so I really enjoyed the book called Beginning C# Programming by Jason Lim. I think it's just short and to the point. It really is just a logical introduction. I can just go ahead and put this in the chat here in case I pronounce something wrong. There you go. So it's in the chat, and yeah, it's pretty nice. But only the first part. The second part gets crazy. Don't go into that kind of stuff. It's really not beginner minded. Are you planning on making your own complete game for sale? Not a tutorial, but some longer game you could submit on Steam, for example. That would be super exciting to do at some point in the future. It's not something that I am working on at the moment, but I will definitely want to create something at some point. But really, all my energy right now is just going into helping you guys as much as possible with all of that stuff to Patreon and with videos and all that, I really wouldn't have time to create a game on my own. And if in the FPS tutorial, will I make a tutorial on picking up guns and switching guns? Maybe weapon switching. That would be exciting. Maybe weapon customization. It's something I get asked a lot. Maybe some picking class selection screen. That would be exciting as well. But I won't go ahead and promise anything just yet. But just know that I'm definitely looking into that stuff. I think we need, after having taking a look at the user counts and data serialization and all that, I think we need to think of ways that we can expand that series, and that would definitely be on the list somewhere. Cool. Yeah, my cat killed the mouse. That's funny. Let's see here. When will multiplayer FPS 25 episode come out? When I make it. I will get around to that very soon. As I said, a video airs in just an hour on my Ludum Dare entry. I'm really excited about that. And that means, because today it is Wednesday, that I will probably I will probably have a multiplayer FPS video out on this Sunday. So I try to upload Wednesdays and Sundays. Okay, and that is on a priority right now. So, yep. Are you going to do more live stream? I hope that means that you enjoyed this. I sure think it was super fun. I am going to do more live streams. If you support the Patreon, it allows me to do more. But I will try and do it as often as I can. At the moment, the limit for the Patreon tier that we just reached is 1 a month. So you have one guaranteed live stream each month. Also, you're free to leave some suggestions as to what kind of content you want to see in these. I just thought I would go ahead and just make something so we have something to discuss here. But we could do something just completely Q&A oriented, or something more community oriented. This was a lot of just me doing a live tutorial basically. So we'll see that. I will consider donations on Twitch. This was just my first time, so I wouldn't want to bombard you or me with information. But that is definitely something that I could look into. But for now, the focus is on Patreon. Should people want to. I think we're getting towards the end here, guys. Final questions, and then we'll do some wrap up. My voice is slowly quitting on me, and frankly, if I have to package this up and all that, the workday is already very long. Let's see here. Final questions. Yep, I should do that. Is it possible to change languages inside the game in Unity? I'm not sure what you mean, if you're talking programming language or like languages that we speak, but it is definitely possible. Yeah, there are plugins that help you change speaking languages inside of the game, so you can get the game out to more users in other countries. Definitely, it's as simply as changing out a string. And yes, you can also have multiple programming languages in one project, but it is not a good idea, frankly. Did I do the monthly subscription for Unity Pro? No, I purchased it through StudyCamp, which gave me some student discount once went back when I was still a student, and back when they had when they didn't have this sort of payment model. But I did purchase Unity Pro. But I think now that they've switched over to all of this client stuff and cloud stuff, it's really not necessary. I wouldn't do that unless I had the money. Of course, don't buy something you don't have the money for. But I would only do that if I was a full-time developer. I should make a Q&A about myself. That is a good idea. I'm actually working on a setup video that will show some of the gear here because there are a lot of people have been asking. So that is something that you can look forward to. IKEA glass. Yes, that is correct. Am I going to upload this to YouTube? As I said earlier, I will try to. This will probably be stored on Twitch servers. If I find it worthy, I will definitely upload it to YouTube, and if everything works out. So I'll try and do that. How did I discover C#? Through Unity, actually. I started... that's not entirely true. I did some programming before I discovered Unity. And a bit of it involved C#, but really it was just the need for a more solid and like syntax heavy programming language than JavaScript. So I started with JavaScript in Unity and quickly found that that was limiting and led to issues. I mainly want you cannot get the dark gray background for the engine with Unity Personal. That was my number one reason for buying as well. Now alarms are going off all the way, all over the place. So I am going to stop the live stream here, guys. Thank you for being so awesome and so positive about everything. I really, really had a blast. Let me know if you want to see more of this. Patreon is there, YouTube is there, everything below. You know how it goes. So yeah,